Hello, everybody. Today we're going to talk about solving linear systems by graphing. There's several different ways to solve linear systems. We'll talk about what a linear system is, um, and there's several different ways to do it. The first way we're going to do it is by graphing. And we'll cover all these terms: solution, consistent, inconsistent, independent, dependent, and then we'll do some examples at the end. So let's go ahead and get started. A solution: an ordered pair that satisfies each equation. So we're dealing with something like this: 2x plus 3y equals 7 and y equals negative 2x or 2/3 x plus 6. Something like that. Um, we are dealing with two different equations. Okay, now, and don't, okay, so we have two equations here. Think about it this way. These aren't the equations for these lines, so I'm going to erase them. But we're going to have two lines that are being graphed. Every point on this line is a solution for the equation. And then if this second line gets graphed, every point on this line is a solution. Now the only point they share is right here, and that's the point we're looking for because it will satisfy each equation because it is on this line and this line. So that's what we're looking for, is we're trying to find an intersection. Now there's some goofy things that happen that we'll talk about. A consistent solution is a solution that, or is a consistent system, is a system that has one solution. So when you graph it, they only intersect at one point. Now you're probably saying, well, how in the heck would they intersect at more than that? Well, we'll get into that. An inconsistent system is one that has no solution. Well, when is a situation when these graphs would have no solution? It would be when the two lines would never intersect. So it would be when the two lines are parallel. And what are you looking for parallel lines? Slope. If the slope is the same, those two lines are parallel, they will never intersect. That system is inconsistent because there is no solution. Okay? Independent. Okay? A consistent system that has one solution. So we've been there. We've been there. We know what that looks like. It's going to intersect at one point. Okay? That is an independent, consistent system. Excuse me. Dependent. A consistent system that has infinite solutions. Now, this is a little different concept. But if I've got a line here, and I've got a second equation that is on the exact same line as the first, every point on both of these lines is an answer, right? Because they're the exact same lines. The lines lie right on top of each other. So there are an infinite number of solutions. So you have three choices. You have 0 solutions, 1 solution, or an infinite number of solutions. Okay? This is inconsistent. This is consistent and independent, and this is consistent and dependent. Okay? So, away we go. Let's do some examples so we can see what we're doing here. First thing I got to do is graph the lines. First thing I got to do is graph the lines and see where we're at. Okay? I'm probably the best thing to do here is let's just go ahead and solve for y. Okay, so I don't have as much guesswork. So 2x plus 5y equals 6. So we subtract 2x. 5y equals negative 2x plus 6. Divide by 5. Y equals negative 2/5 x plus 6/5. So real rough, 6/5, and then we're up, or down 2, down 1, 2 over 1, 2, 3, 4, 5. So we're in here somewhere. Graph looks like this. Okay, now let's solve this second equation. I'll do that over here. So we subtract 4x over, so 10y equals negative 4x plus 12. I divide by 10, so y equals negative 4 over 10x plus 12 over 10. Okay. Well, if I reduce all these fractions, y is going to equal negative 5 halves x plus 6 halves. What do you notice? This equation and this equation are exactly the same. I have the exact same starting point. Every point is shared. So therefore, this is a dependent system because it has it has an infinite number of solutions. Dependent system. Okay? An infinite number of solutions because the lines lie right on top of each other. Okay? Let's do this second one. Okay? What do we notice here? Well, hopefully we notice something. Let's go ahead and solve this first one. Negative 2y equals negative 3x plus 10. Just subtracting the 3x over, divide by negative 2. Y equals positive 3 halves x minus 5, because a positive 10 divided by negative 2 is negative 5. So I go down to negative 5, up 3 over 2, up 3 over 2. Graph looks something like this. Okay, we're in good shape. Now, let's do this one. Negative 2y equals negative 3x plus 2. Y equals positive 3 halves x minus 1 when I divide by negative 2. So I'm down here at negative 1. And this time I am up 3 over 2. Up 3 over 2. And what do we notice? Well, hopefully we notice that the slopes are exactly the same, which means these two lines are parallel, which means there is no solution. They will never intersect. This is an inconsistent system. Inconsistent, because there is no solution. They're parallel. They will never intersect. Okay. Last one. I'm gonna solve down over here where I got a little room here. So I add the 2x over. Well, this one's easy. Y equals 2x plus 5. Okay. So I'm up 5, up 2 over 1, up 2 over 1. Graph looks something like this here. Okay. Last one, y equals negative x plus 2. Negative x plus 2. Well, that means I'm up here at 2, and negative x means down 1 over 1. So that looks like right here, my graph does this. Now, it looks like the intersection's right there. Now, if you have, this is a consistent independent solution, or system, because it's got one solution, it's got one intersection. You need to check and make sure your solution is correct. Okay? So what are the coordinates of this point? It's negative 3, 1. Okay, well you need to make sure that negative 3, 1 is going to make each equation true. So let's take each equation. So I've got negative 2x plus y equals 5, and let's plug in negative 3, 1. So negative 2 times negative 3 plus 1 equals 5. Oh, I got the wrong point here. I don't know what I was doing. This is negative 1, 3. Sorry. I was wondering why that wasn't going to work. Negative 1, 3. So now I've got negative 2 times negative 1 plus 3. There, that's better. Equals 5. This is a positive 2 plus 3 equals 5. 5 equals 5. Now you're not done, because all you've done is proved that that point is on this line, which is good. But for it to be a solution to both, it's got to be on both lines. So let's do the red line here. Y equals negative x plus 2, and plug in your point. 3 equals negative 1 plus 2. 3 equals 1, positive 1 plus 2. 3 equals 3. So since they both work, since you get a true statement at the end, 3 equals 3 and 5 equals 5, you know that this is the answer, -1, 3. Okay? So I went through a type of each, okay, where we had dependent, inconsistent, and consistent independent. Okay? 0 solutions, infinite solutions, 1 solution. Okay? We'll work some more of these in class, answer any questions you may have. Hopefully this makes a little bit of sense. Might be new. I know you've done it before in Algebra 1, so it shouldn't be too new. We'll clean up any questions you have when you get to class. See you there.